we can divide speed into two types. We have two types of speed. If we have two objects, the first one will move with same distance in same time, and another object move not equal distance and in not equal time. So we have divided speed into two types: uniform speed and the second one not. The first one, uniform speed, we have here object move from the point A to the point B 20 meter, and from point B to point C 20 meter, and from point C to point D 20 meter in the same time, in each case 2 seconds. Okay, we have here another object move from A to B. It moves distance 1 20 meter in 2 seconds, and distance 2 10 meter in 2 seconds, and the last one 40 meter or distance 3 in 2 seconds. So we have speed in which the body covers unequal distance in equal time, and the second one, we have another example. We have here body covers unequal distance but in equal time, and the second case here we have another object move equal distance. It covers d1 equal d2 equal d3 20 meter, but it covers or takes different time, 2 second, 4 second, and 1 second. This means that here the speed in which the body covers equal distance in unequal time. So we have the first one here, uniform speed, body covers equal distance, here the first case, in equal intervals of time. But the second one, we have non-uniform speed. It means that body covers unequal distance in equal time or equal distance in unequal. Okay, if we take the uniform speed, the first one, body covers equal distance in equal intervals of time. This means that the speed is constant by the time covering, or by the time the speed doesn't change. Okay, this means that the speed is constant. We can measure it, or we can call it the speed is constant or body in a constant motion. Okay, the second one, non-uniform speed. Speed here is not constant. Why we called it is not constant? As we cover equal distance in unequal time, or unequal distance in equal time. The first case, v1, we have distance here, d over t 20 over 2 equal 10 meter per second. Speed 2, distance over time 20 over 2 take also 10 meter per second. In the third case, speed equal distance over time, it covers 20 over 2. It means the same, equal 10 meter per second. So here v1 or speed 1 equals speed 2 equals speed 3. Okay, non-uniform speed, here we have v1 equal distance over time 20 over 2 equal 10 meter per second. v2 equal d over t equal 10 over 10 equal 5 meter per second. We have here v3 equal d over t equal 40 over 2 equal 20 meter per second. Look at every speed here. We have the first case 10 meter per second, the second case 5 meter per second, and the third one 20 meter per second. Okay, so we have v1 not equal v2 not equal v3 as whole, all of them not equal v2. Okay, so we have here uniform speed. If we take total distance as we take before divided by total time, this means that the body move with a uniform or regular speed only. We can take that v1 or speed 1 equal speed 2 equal speed 3 equal speed. So we have here total distance divided by total time gives the same speed equal 10 meter per second. In each case, if we divide distance over time, we will take the same result for the speed. We have 20 over 2, 20 over 2, 20 over 2. We will take total 60 over 6, and we have 10 meter per second as it is. So we have here average speed. So average speed for the regular body or the body make uniform speed equal the same speed in any time. We have another speed, non-uniform speed. Non-uniform speed, it means that average speed here for a irregular body, we have here total 20 plus 10 plus 40 divided 2 plus 2 plus 2. The total will be 11.7 meter per second. So V1 not equal V2, not equal V3, no, not equal the total or the average speed. Okay. We have the last type of speed, we called it relative speed. This kind of speed, we called it a speed of moving object relative to body can take or can measure this speed. We can call it observer. Means the one can see or measure this kind of speed. So we define the relative speed. It is a speed of moving object relative to observer. We have here observer stand on the ground in car A. V1 equal 20 kilometer per hour. And we have here relative speed in the case of observer stand on the side of the road without motion. The observer stand on the ground without any change in its motion. So it can measure the speed of car B. So here speed of car B equal, or the speed of object relative to observer equal the object speed. So the speed of car B equal 50 kilometers. We have the second one here, relative speed in case of observer in a state of motion in a car. The body can change its position, not stand on the ground. Okay. The first case, if the two objects move in the same direction with each other. So we have observer here in car A, inside car A, and its speed V1 equal 20 kilometer per hour. And we need to, or observer is a passenger, and we can measure the speed of car B, V2, here equal 50 kilometer per hour. So if we can measure the relative speed, so the object speed, car B that we want to measure its speed, minus observer speed. So the relative speed means that we can measure the object speed minus observer. Here we have object speed car B that we want to measure. Car B 50 minus 20 here, V2 minus V1, relative speed here equal 50 minus 20 equal 30 kilometer per hour. So if we have two objects move in the same direction, here we have object speed minus observer speed. If we move in the same direction, we have relative speed in case of observer in case of motion, but the two objects move in opposite direction. Here we have observer is a passenger in car A, V1 equal 20 kilometer per hour, and car B move in opposite direction to it, V2 equal 50 kilometer per hour. The same rule, we have object to measure object speed, relative speed equal object speed minus observer. So we have object speed here, car B 50, negative or minus car observer speed, the car A means it opposite direction, minus, so it will be plus. We have here relative speed equal V2 plus V1, so 50 plus 20 equals per hour. Okay, we have here word problems for it. If we have car A move with the speed 60 km per hour, car B moves in the same direction with the speed 90 km per hour, find the relative speed of car B relative to an observer. In the first case, stand on the ground, and in the second one, in car A. Okay, relative speed of car B equal, if we stand on the ground, relative speed of car B equal its real speed of car B equal 90 km per hour. In the second case, relative speed of car B equal V2 minus V1 if they move in the same direction. So we take V2 minus V1, 90 minus 60 equal 30. Okay, we have another problem. Two cars move in the same direction. Car A moves at speed 30 km per hour and car B moves at speed 80 km per hour, while car C moves in opposite direction at 40 km per hour. We have here calculate the relative speed of car B to observer, which is, in the first case, stand on the ground. We have here real speed of car B equal 80 km per hour. Okay. So we have, if the observer stand on the ground, so the speed of observer equals the same speed of car B, means it will be 80 km per hour. If we want to measure relative speed, if observer in car A, so it will be 80 minus 30 as they move in the same direction. We will take 50 km per hour. And the last one, if the observer in car in car C equal 80 plus 40 equal 120 km per hour. Note that measuring relative speed depend on the of